refresh rate of the light and the refresh rate of the camera, you look like you've been kidnapped by the guy from Saw.
Let me
Anyway, hi out there, folks. This
film this off
is
if I
the
can.
May Hackster Impact Spotlight on the theme of industrial automation. You might notice that the hosts here look a little bit different than you're used to, but thank you for joining us. I'm Phil Nelson, your co-host with the co-most, the second banana who's second to none. I'm also your plus one and only. It's Mr. Nelson if you're nasty, but you, my new friends at Hackster, and my old friends on OpenCV Live can call me Phil. And I'm here with a man who's apparently been kidnapped by Jigsaw, Dr. Satya Malik, the computer vision doctor. He also has a bachelor's degree in style, as you can tell by that sweet hat and jacket he's got on right now.
Right.
How you doing today, Doc?
Doing good, doing good. This is going to be a great show. And just by the way of introduction, I'm the CEO of OpenCV.org, and some of
Mm-hmm.
you may know that OpenCV is the biggest computer vision library in the world, downloaded about 1 million times a day, and
Mm-hmm.
it's the library that was used in
Don't
NASA's
forget Stanley. Yeah.
yeah, in Stanley, which was the first autonomous car to cross the Mojave Desert and win the DARPA Grand Challenge in 2005. And it is also the library that was used by NASA recently in its
Mm-hmm.
Mars helicopter. So,
That's right.
yeah, short
OpenCV has
introduction.
been on the friggin' moon, Earth's moon, as well. With some of our stuff was used on the Blue Ghost project. Is that not correct as well?
That's right. It's used everywhere.
Yeah, OpenCV is used everywhere, and we want to quickly thank our members and partners. OpenCV is a nonprofit organization. We're super happy to be able to bring this stuff to you. Also, OpenCV has a related project here, the Perception for Industrial Robotics Automation Workshop on in CVPR this year. CVPR 2025 is in Nashville, Tennessee. We're going to Music City, and we're going to have a lot of fun. Hopefully, we'll have a lot of fun. We're going to hold on here. Let me try to. Yeah, my screen share is not working. It's fine. But yes, hi in the chat there. Please, as you join us here, we're going to bring something from the OpenCV live show into the Hackster show here. As you join, please let us know where you're joining us from. We love to see the global audience of makers and creators chiming in the chat. It's a thing that we love doing every week. So yeah. Quick note, Doc. So you've been a busy little bee this month with a whole lot of various workshops and talks. How many talks has it been over the last 5 weeks?
It's been two talks which were on OpenCV 5. We are going to release OpenCV 5 this summer, and this
Mm-hmm.
was both excitement and warning about what are the things that are going to be exciting about OpenCV, and what are the things that we are going to break in OpenCV. And then I also had two workshops on two different topics: a 2-hour workshop on image segmentation, and then a 3-hour workshop on vision language models. And the first one was in Display Week, and the second one was at Embedded Vision Summit.
All right. Yeah. Super fun events. There were, big ones in the Bay Area. Display Week, I think they said it was like 8,000, 7,000 attendees,
Yeah,
something
huge number
like
of
that.
people.
Pretty wild. Embedded Vision Summit a little bit smaller than that, but like much more focused on stuff in the OpenCV wheelhouse, embedded robotics, cameras, things like that. We've got Steve Bell joining us from Athens, Georgia. Howdy, Steve. This morning got BG Seti joining us from Hyderabad in India. Looks like we've got a few people on LinkedIn coming to us from North Carolina, North Kakalaki. My dad's from North Carolina. But yeah, I think now is a great time to get started with today's, the focus of today's show, which is a couple of really awesome projects from the Hackster community. We're going to start here with the first one, which is RetroLogger. I'm going to share the Hackster. I'm going to try to share my screen here and share the Hackster project page for RetroLogger. Jesselyn, if we can get that up on the screen, thank you. So also, don't everybody say hi to Jesselyn in the back end there. Thanks so much for running everything and making us look good. RetroLogger is a project from Mukesh Sankla. I believe I pronounced that name correctly. It's an ESP32 based Internet of Things data logger built specifically for legacy industrial machines. I love projects like this. One of the reasons is there's a huge amount of infrastructure out there that is just extant already. Like these are machines that have been being used for like 20, 50 years. And mostly in technology, I feel like people love talking about the new stuff and replacing all of the old stuff, but much of the time that is simply not necessary. Like the just
Yeah.
because the machine is old does not mean it needs to be replaced. You can augment them. You can kind of retrofit them. And I think this one is really cool. It's using the DF Robot Firebeetle ESP32 IoT microcontroller. It's got built-in Wi-Fi and Bluetooth. It's a neat-looking little package that they've created here. You can find this on Hackster.io. We'll drop the link in the chat there. I think now let's take a look. They made a video for us. Let's go ahead and take a look at the video there, if you don't mind, Jesselyn.
Hey everyone, thanks to Hackster community for inviting me for this month's Impact Spotlights. I am Mukesh Sankla. I graduated as a computer science in 2022 and then joined Siemens. In Siemens, I was responsible for developing in-house software and implementing the end-to-end industrial IoT solution. So here I used to develop software. On the other hand, I used to connect these production line machines to the database using some hardware. Apart from this, I also introduced 3D printing to my elderly colleagues so that they can leverage the capabilities of 3D printing in building the in-house parts. In that factory, I have learned many things like how a product is built, how it is produced, and how it is sold to the user or the customer. Now I have quit my job and I'm doing full-time content creation and building this brand called MakerBrains. With MakerBrains, we are producing high quality content on topics like electronics, 3D printing, software for professionals, students, and makers. Also, we are providing hands-on workshops in South India region on the similar topics. In last 5 years, I have built around 30 plus open source projects which you can find on my Hacksters profile. So these projects teaches the viewers how a MVP is developed. So how a person can convert his concept into a product. Basically, they teaches how to CAD, fabricate with 3D printing, or pick the electronics, design the PCBs, write the code for the electronics, and build a mobile application or a web app for the product. For today's Impact Spotlight, I have my latest project, RetroLogger. As we know all, in today's world, everything is being connected to the internet. But in manufacturing and in industry, there are many production lines and machines that are old and they cannot be connected to the internet because they were never designed for those kind of tasks. They were only designed for producing the parts or the product. But now, since everything is AI, everyone needs AI to be implemented in their processes. Especially in manufacturing, if you see, they want to optimize their process, they want to optimize their efficiency and the quality of the products, right? And AI is helping for this kind of enhancements, right? But for AI to run, we need tons of data. But if our machines are not generating data, that means we are losing the AI capability, right? So the solution is straightforward. We can just replace these old machines with the new, which has new standards, new communication methods, and connectivity to the internet. But that means millions of investment, months of downtime, and still to reach the accuracy and reliability of old machine, it takes around 1 to 2 years, right? So that's lot of hustle. But what if we can make our existing old machines smart? So the plan is simple. We need a device which can communicate with our old production machine with old communication protocol and translate it to the database or the cloud. and this need to be done keeping security in the mind, which means our gateway device should not be tampered. If that gets tampered, the data can be redirected to any other source. So for this project, I have took simple ESP32 with a spring type terminal connector and 4 box LEDs for indicating the status for power, for Wi-Fi connectivity, receiving data, and for syncing the data to the cloud. For the design, I have built this enclosure in Fusion 360, which has 3 parts: a base where our ESP32 and the uh, terminal connector sits, and then I have another part where we mount all our LEDs, and then we have a cover. So for the build, it is very easy. We just need to connect the LEDs, connect the ESP32 and the terminal, and that's it. Just close the enclosure. Coming to the security part, like I have written the full code in ESP-IDF. Then what I have done is I took the bootloader file and the app image file and uploaded them to the Thistl's secure boot signaturing tool. Okay. Here, like Thistle is playing a great role for providing security services for not only ESP32 devices, but also there are many other devices that they serve for, especially for industrial devices. Okay, so you can check them. So here, what I have done, I have took my bootloader image and the app image and signed them with the authenticated encryption. And then I have flashed my retro logger, and here in the testing you can see a Arduino sitting. Since I don't have a full production machine in my home, I took a Arduino Uno where I have written a code which simulates a production line, which means it generates random data uh, of a relay production machine. So we have this relay, right? So it simulates the winding and the testing parameters of that relay. Okay. So here it is communicating using UART, which is serial communication, and taking the data. The retrologger is taking the data and syncing it to the cloud. With cloud, I mean Google Firebase. So as you can see, this is the data which is being uploaded to the cloud. So this was the basic idea to turn our old production machines with internet capability. Here you might have lot many questions like, what is this? Why will industry use this? Who is the user, right? So I have designed this project especially keeping in mind the education part. Like I want to uh, educate especially the students so that they can at least get into basics of IoT. But then there are many small companies who cannot afford big hardwares, but they want their machines to talk to the cloud and get the AI implemented. Here I have heard many stories from the internet, like after publishing this project, that they are also using as simple as ESP32, connecting their old machines to the ESP32 and transferring the data. So I think it proves that there are some user base, right? So that's it. If you want to contact me, you can contact me on these platforms, and you can view my all my projects on hackster.io. Thank you.
Yeah, thanks so much, Mukesh. What a fun project. Like I said, I'm a big fan
It's a
of
fun.
retrofitting tech. Like I love seeing stuff like this. We should definitely, hopefully, we'll see more from this awesome creator. Yes, and folks in the audience there, one of the things we do on OpenCV Live and here on Hackster Impact Spotlights is take questions from you in the audience. If you've got thoughts or questions about the projects here today, please post them in the chat wherever you're watching. We're live on YouTube, we're live on Twitch, we're on LinkedIn Live video as well, and hopefully soon they will approve us for TikTok live streaming as well, because they do horizontal video on TikTok live streams now. Ain't that something? Will wonders never cease? Yes, and we're also dropping the links to all of these projects in the chat on YouTube, etc. So if you want to find out more about them, you can head on over to the handy dandy Hackster project page for each one of these projects. And if you have a project you'd like to see on a Hackster Impact Spotlight episode like this, the best thing you can do is upload it to Hackster. Tell folks about it, tag it correctly, and maybe it'll pop up on here. It could be you. It could be you.
Yeah, one of the useful computer vision retrofitting projects that I feel that somebody should be doing, and I'm pretty certain that a lot of people are doing it, is basically reading gauges, right? Old gauges and meters using.
You're coming for the meter man's job now.
Yeah, I mean, the meter man can only visit once a month or whatever it is, right? But with these cameras, very lightweight cameras, which they can last a couple of years with a single battery. They just wake up every day at the same time, take a meter reading, and send that data to. They take a snapshot of the meter, read the meter, and then send the data over. So that's
our friend Kwabena from OpenMV. One of their big use cases for their cameras is these super low power, occasional, just wake up real quick, do a photo, send it, go back to sleep.
Right.
Super cool setup. Let's keep the show rolling here. We've got our next project is DC motor position control with a potentiometer for robotic arm by Ivan Nestorovsky. Hopefully I pronounced that one right. Could be Ivan, I'm not sure. Sorry about that, whoever that is. I'm going to go ahead and share my screen here, and we'll take a look at the Hackster project page for this. It's a cool looking one. You should be able to see that now, Jesselyn, and thank you. So yeah, you know me, folks, if you've seen any of the shows that I've ever hosted or even read anything that I've written, you'll know that if I love one thing, it's robot arms. It's just such a symbol of the future to me. I think just going all the way back to, the Terminator, right? The last kind of images of that film is the
right.
So it's just one of my faves. And this one looks like, look at all that wire wrapping in there. This is some serious stuff. This is like 1985 Steve Wozniak stuff here. I really like it. So yes, replacing servos with DC motors and potentiometers for precise, cost-effective robotic arm control. Obviously, and there's another Arduino Uno here. I mentioned in the chat here, but the Arduino Uno, one of the most consequential, possibly the most consequential single board computer maybe ever made, right? I've got 3 of them back here. I still, hey, my 3D printer needs the firmware upgraded. It's time to bust out the Arduino. You need to trigger some lights based on something. I better grab the Arduino and an RF input. It's a super useful little guy, and they've been making them for it's got to be 15 years at this point, at least 10, right? Gosh. So yeah, go check out the Hackster project page here. We'll drop the link in the chat. We've got a whole story about how to create. We got the, if you want to build one yourself, I love how easy Hackster makes it to document these projects and build your own and do some modifications. So let's go ahead and watch the video now.
Hello everyone, and welcome to the Hackster Industrial Automation Impact Spotlights. My name is Ivan Nestorovsky, and I'm excited to share my project on DC motor position control with potentiometer for robotic arm. This project focuses on creating a cost-effective and precise way to control robotic arm movements using readily available components. My journey into robotic arm control started with exploring precise motor positioning. Standard DC motors are great for speed and power, but they lack the built-in feedback needed for precise control like positioning to a specific angle. Servo motors overcome this by including feedback in a control circuit. but they can be expensive and might not always have the required torque or speed for larger applications. This led me to investigate low-cost alternatives for position control. The inspiration for this project came from two main areas: addressing the lack of precise position feedback in standard DC motors and finding a cost-effective alternative to expensive servo motors. I was also inspired by the principle behind temperature regulation systems in everyday appliances, which helped me conceptualize the closed-loop control needed. My initial concept, which I previously documented, focused on controlling a single DC motor with a potentiometer and Arduino. This robotic arm project scales that fundamental concept to control multiple motors simultaneously. The core idea is the use of potentiometer attached to the motor shaft as a feedback sensor. The 3D printed case and gears are essential here. They house the motor and potentiometer and provide a gear ratio to relate the motor's rotation to the potentiometer's value. The Arduino reads the potentiometer's analog value to know the current position. Desired positions are sent to the Arduino via serial input, which is then used by a proportional control algorithm to calculate the error and determine how to drive the motor. The L293D shield receives the Arduino signal and converts it to a PWM signal to control the motor speed and direction. Scaling this from a single motor to 4 motors for a robotic arm presented a significant challenge, particularly on the software side. I found myself writing the multi-motor control code manually, using an array-based approach in the Arduino sketch to manage each motor's position control loop. Another challenge was creating a user interface to control the robotic arm joints easily. After exploring different options, I realized the power of Python for creating a user interface. I developed a Python-based user interface for the visual elements and the communication with the Arduino. This user interface allows users to control each of the 4 motors representing finger joints using sliders that act like a virtual potentiometer. AI was very helpful in optimizing the Python code for a smoother communication. The use of the 3D printing was crucial for creating the custom gears and cases needed for each motor and potentiometer assembly. It allows for precise fitting and customization. After all, it was only as a proof of concept for me. For the future, I would probably continue refining the control algorithm, potentially exploring more advanced techniques beyond simple proportional control for even smoother and more precise movements. Integrating additional sensors or calibration routines could also improve accuracy. Further optimizing the mechanical design of the 3D printed parts could enhance durability and performance. I also plan to integrate this control system into other robotic platforms. Thank you for your attention. You can find detailed information about both the single DC motor position control project and the robotic arm project on my Hackster profile. My Hackster profile is Ivan Storovsky. All the codes and design files are shared open source, contributing to the maker community and hopefully inspiring others. Please feel free to connect or ask questions through my Hackster profile. Thank you again to the Hackster Impact team for the opportunity to share my work.
Cool ass project. Can I say ass on here? I guess we'll find out. We'd
That's
love to
super
see
cool.
stuff like this, folks. Like, yeah, I mean, there's just something about a robot arm, and
I hope Phil comes back.
one that has.
He is
Am I
still
not here?
loading.
Check one. Uh-oh. You might need to refresh their dock. I think I'm here. But anyway, up next, we've got some more for you. But first, let's
All
talk
right.
a little bit
Well,
about.
So yeah,
OpenCV.
I would love to hear some comments from people who are listening. What do they think about the this position controller? I feel that it is super cool. Something, one of the things that that is difficult in all of engineering is creating something, even if it is a prototype, creating something from scratch that works, right? And here, I really enjoyed how the person had Ivan had a working prototype, even though it is based on simple algorithms, right? but it is able to create something which is a working prototype.
Yeah. Can you hear me now, Doc?
Yeah.
You good? Okay.
You're
So,
back.
one of the things, another thing that I really like about Hackster here, and something that folks should be aware of, is OpenCV has our own little hub, as many projects do. And so I'm going to take this time to just quickly share the OpenCV project hub here on Hackster. If you can put that up on screen, thank you, Jessalyn. So yes, the open source computer vision library. We got to update this number. It's more like almost 40, I think, at this point. Something like I think it's 35 million times a month we're downloaded now. But yeah, so on the hackster.io/OpenCV page, you can find the most popular OpenCV related projects uploaded to Hackster recently, and also go into the fire hose, see the newest stuff. I don't know what the Goon Squad is, but I do like the movie The Goonies. Autonomous RC car that uses OpenCV for lane detection. Hokey smokes! All right, we're gonna have to look up this one offline, maybe after the show.
Yeah.
Just using a Logitech camera. All right, cool stuff. So yeah, hackster.io/OpenCV. You can also find stuff like hackster.io/Arduino, hackster.io/OpenMV for specific projects and platforms like that. Yeah, up next we've got our third and final project for today, and then we'll take some comments and questions from the audience. So please, folks, if you'd like to chit chat a little bit, if you got some questions, post those wherever you're watching, and we will do our best to bring them up here on screen. Here on the Hackster StreamYard setup, we can even post your stuff on the video here. So get yourself your 5 seconds of fame. Let's take a look at. I'm going to stop sharing here. Let's take a look at our final project, which is Remoto, great name, an IoT plug-and-play firmware for MQTT. I'm going to bring up the project page right now. And yes, okay, I got it. If you can bring that up for me, Jessalyn, thank you. And we've got Remoto IoT plug-and-play firmware with MQTT. For folks that don't know, MQTT is a sort of lightweight messaging protocol. Essentially, it's a really low-calorie way for these small microcontrollers to communicate with each other and subscribe to messages from each other. This one is OPTA with MQTT. How many acronyms can we cram on here? FCC, UL listed. So we've got an Arduino Opta. This one's pretty interesting. It's got built-in Wi-Fi, it looks like, and for remote telemetry and control. This reminds me a bit of we got a nice little user interface here as well. This reminds me a bit of our friends from the Drone Code Foundation. I think we're going to learn a lot from the video on this one from creator Alberto Pero. Let's go ahead and check out the video.
Welcome, I'm Alberto Perro and I'm presenting today my project called Remoto, an IoT firmware for the Arduino Opta. First of all, I want to thank Hackster for giving me the opportunity to present my project at the Impact Spotlight event. Let's introduce myself. I'm an applied physicist specialized in data acquisition systems, and I have over 10 years of hands-on experience with Arduino platforms. I've always been an advocate for open source solutions in industrial automation in my past and current jobs. And I always wanted to share my knowledge in this field. And to do so, I taught some courses in electronics and rapid prototyping for non-STEM learners ranging from kids to adults. I also wrote some tutorials on home and industrial automation on Hackster.io. The project I focus on today is Remoto, which is an IoT firmware for Arduino Opta. The idea for this project started some years ago when I was working for a company and this client needed a cost-effective, flexible remote monitoring solution for water distribution system. We wanted to explore Arduino in this industrial application for its modern expandable features and lower cost compared to the industry competitors. So what we did, we developed a complete solution starting from the device, which at the time was the only Arduino-based industrial certified platform, which was the Industrino, and then used MQTT for the network protocol and Node-RED for displaying all of the data like a SCADA system. So we delivered a robust system that is still in production today after, I think, 5 years. And the client was satisfied with the product. But unfortunately, the limited knowledge in programming of the client limited the possibility to further customize it from his side, always relying on somebody else to develop the code for him. So this experience inspired me to create Remoto, a user-friendly platform for industrial IoT. This all started when the Arduino Opta came out, and therefore I thought it was the perfect platform for this project, and I began developing new firmware focused on no-code setup for basic functionality, making industrial IoT accessible to non-programmers, and giving the possibility to users to just get your Opta and get running out of the box. So the bill of materials for this project is very basic. You just need an Arduino Opta of any version, and for the software side you need the Arduino IDE to program it for the first time, and the MQTT server to connect to share the data. So the design points are the fact that Remoto offers a simple interface showing the status of the device I/O remotely. It uses Ethernet and Wi-Fi, depending if you have it on your Opta, and it supports both DHCP and static IP configuration to suit your needs. It mainly focuses on MQTT, so it has an MQTT client that publish the telemetry data and also can execute control commands like toggling a relay. There is also a REST API which gives similar opportunities as the one given by the MQTT, like telemetry data. It also gives the opportunity to configure the device and soon to control the device also via this HTTP REST API. To give a very nice interface to the user, I developed a very simple web server interface that gives all of this information through a web browser. So it allows real-time monitoring of the status of the device and configuration. This is actually the key feature, and the goal is to leverage the network connectivity of the device and the power of the device to show all of the status via web page. And with this intuitive web page, the user can instantly verify the wiring and the configuration of the device without any need for specialized software or coding skills, just by using its smartphone or laptop. And it simplifies and troubleshoot all of the problems that could be in the setup for all of the users. The user should be also able to configure the device without any coding skill. Therefore, there is a dedicated configuration page on the web server that allows the user to customize the settings without touching the source code. And this configuration is saved locally on the device. As I said, also the key point is the integration with MQTT. This MQTT client both serves telemetry publishing using topics, which are device ID, which is configurable by the user, the type, which is input and the number of the input, and the attribute, which is either the value or the type. Type means analog or digital. And also you can have control commands, which allows the control of the output pins or relays on the board. So you have again a device ID and O for output and the number of the remote pin. Similar features are also available through the REST API. So telemetry data can be retrieved using the HTTP GET request at this address, and this will give you a JSON object as shown here with all of the information on the device. So this was the project. In the next steps, I would like to find more contributors because I'm the only one working actively on this, and I do it in my free time. So I cannot implement many features alone. I don't have much free time. And on the more technical side, I would like to add support for the Arduino Opta extension modules and support for the RS485 Modbus RTU devices. So if you're interested in the project and you want to contribute, please go on GitHub on the project repo and open issues or pull requests to further interact and improve the project. So I want to thank again Hackster for giving me the opportunity to present to you the project. And here you find all of the relevant links to make it yourself and to get in contact with me if you want to develop this project. Thank you.
Folks. So yeah, another great example of someone just having a problem themselves or seeing a problem, solving it, and sharing it. I love that. That's really
Sorry.
It's really
Phil
the
is
basis
loading
of
again.
open source. I'm here. Don't worry about it.
Should be
I'm
here.
going to go ahead and
All right.
I'm going to go ahead and share my screen here, and we're going to talk a little bit more about Hackster Impact Spotlights. But any thoughts about that project, Satya?
Yeah, I mean, so the basic idea, right, to make it user friendly for people who do not have access to, do not have coding skills, that is very extremely relevant, right? I used to like when I started programming in C++, right? And after that, when I
Because you're old.
that's right. When I learned about when I started programming in Python, it almost felt like, oh, it's cheating because it's so easy. You don't have to do any memory management, nothing, right? So but I also realized, right, that this higher level of abstraction, and obviously Python is not as efficient, but still you go to a higher level of abstraction, and now you can imagine that now people are talking about coding using natural language, right? So the more intuitive it becomes for people without specialized skills, the wider the adoption is, right? And that is why we see that Python has taken over in a very big way. And that is why when things become easy, more creative people are able to join the field, right? Not necessarily technical, but more creative. And even for technical people, it becomes easier. So this kind of project I really love because it makes things accessible to people who would otherwise not be interested in this kind of field, right? So I really like the project.
Yeah, agreed. Couldn't agree more. I think that's a big part of it. I mean, I joked earlier because you're old, but I think I'm a couple years older than you.
Oh, you are?
I learned. I'm pretty sure I am. I learned. I actually learned how to program on an Apple II with Basic. So
Oh,
like
okay.
I learned how to program on a green screen computer where you can actually see the lines on it. And very little has changed. No, I also became a Python guy. I think pretty. Gosh, I've been writing Python for like 20 years now. It's so weird to think about.
Right.
But yeah, huge thank you and shout out to our featured projects here, Makesh, Ivan, and Alberto. Thanks so much for submitting these and making your videos. I think folks don't. Maybe if they've not done this, they don't realize how tough it is to present a project. Like it is sort of scary to have to summarize and make a nice, easily digestible, condensed version of your hard work. And I think all these projects did a really great job. We've got a little bit of time left here, so now I would like to talk a bit more about Hackster Impact Spotlights. This is, of course, the May flavor edition of Hackster Impact Spotlights, but there's one of these every month, folks. And so we're going to pop open the webpage there. If Jesselyn, thank you, Jesselyn. Just super on point here today. So yeah, Impact Spotlights are free monthly events that highlight community of the Hackster community of engineers and the technologies that help them develop solutions to enable a better world. Last month was AI in the wild. Next month will be Edge AI. You can go find these at events.hackster.io/impact spotlights. Don't forget to RSVP and subscribe to the newsletter for announcements. And of course, you can find the recordings of all these episodes on the Hackster YouTube channel and on LinkedIn Live. You can also just go to the hackster.io/events page to find awesome events all around the world at all times. Right now, I'm super jealous about the folks in Edinburgh for Open Hardware Summit in Scotland. Shout out to, I think Alex is out there. I think Kat Scott, our friend from Ross, is out there as well. I'm green with envy. This shirt is not normally this color. It's not, but also, we've got you can find the next Impact Spotlight. You can find stuff like computer vision and pattern recognition 2025, which OpenCV has not only a booth. We've also got a workshop, the PIRA, Perception for Industrial Robotics Automation Workshop at CVPR in Nashville, June 11 to 15. Doc, can you remember what day our presentation is on? Because I don't. June 12. June 12. There
Yes.
we go. I found it. Okay. Yeah, so if you're in Nashville, come find us. Probably a little bit hungover. So keep the volume down if you can. I will be wearing sunglasses, but not because I'm hungover, because they look cool. No, because I get headaches. But yes, no questions from the chat here, I guess. I think maybe we can call this one it's a little bit early to call it for an OpenCV live episode, but it's about right on time for a Hackster Impact Summit. Hackster Impact Spotlight. Please send those projects in. Contact Jesselyn if you've got something cool to show. And also contact OpenCV. We love seeing your cool stuff. We're going to pull up quickly. OpenCV is a nonprofit organization that makes an open source computer vision library, and as such, we can use your support. You can support OpenCV by going to opencv.org/support. You can donate, you can buy a t-shirt, you can buy a sweater, get a little bandana for your dog. Send me a picture of your dog wearing the OpenCV bandana, and I will absolutely show it on the air. We had about 50 folks watching on YouTube today. That matches one of our all-time highs, aside from the Murtaza episode that we had a ton on there. But final thoughts for the good people out there today, Satya.
Well, I would urge you all to do your own little projects and contribute to the community. It is. I started contributing to open source by starting a blog about 11 years back. More than about 11 years back.
That's learnopencv.com.
Yeah, learnopencv.com. And I'm surprised, even today, people come to me. And at that time, I did not know how many people would actually read it, right? When I first started for the first month, I think there were
never
two
really
users.
know. You never really know.
Yeah, there were two users, right? I had Google Analytics set up, right? And there were two users. One was me from my phone, and one was me from my laptop, right? So those were the two people who used to visit my site.
You got to be your own biggest fan on some level,
Yeah, but then now visited tens of thousands of people every day, and they. I also find people when I go to conferences, etc. I find people who thank me because they used my code for doing some work at their work, or even as a student, and it's useful, right? And the same thing will happen to your project as well. If you build something, you may think that not many people will, it won't get that kind of highlight initially, and that's true, right? When you do start out, you may not get that kind of visibility. But over time, the things that you produce, the content that you create, the sharing you do of your technical knowledge, that will bear fruit. Somebody will benefit from it, just like you have benefited from the community, right? And that is a message I want to tell everybody. Open source is it's a mind-blowing idea, right? We are standing on the shoulders of giants, and it is our responsibility to contribute back to the community.
Couldn't agree more, Doc. And I mean, people may not know this, but honestly, learnopencv.com pretty much directly resulted in you becoming the CEO of OpenCV. Is that not
Yeah,
true?
that's right.
Yeah, like
That is
you
right.
never know. From
Yeah.
2 users, both of which were him, to CEO of the nonprofit. So
Yeah,
I
so
mean,
Gary
that's-
Bradsky, who is the founder of OpenCV, he started noticing whenever I used to publish, he started noticing, and sometimes I used to talk to him at conferences, and he would recognize me because I had this blog, right?
pretty great. We have fun stories in open source and computer vision. Yes, so please check out the next Hackster Impact Spotlight. That'll be next month. The theme is Edge AI. We'll probably see a lot of familiar faces to the OpenCV audience. I don't know who's going to host it. Maybe it will be us again. I don't know. But thank you so much, Jesselyn, in the back end. Can we just get a little round of applause for making sure this all ran smoothly? It's a lot easier to talk on camera when you don't also have to click all the buttons to make stuff happen. So thank you so much, Jesselyn, for finding these projects and for doing all of the hard work so we could have a little bit of fun with the audience here today. We will catch you next time. Same bat time, same bat channel, 9 a.m. Pacific time. We will see you next week. Take care of yourselves out there, folks. Take care of somebody else if
Thank
you
you,
can,
guys.
and have a great day wherever you may be.
Bye.